this video, you will learn how to assemble a hybrid cable. Hybrid cables connect Huawei CloudEngine S5732H series hybrid optical-electrical switches to WLAN APs to provide power supply and data transmission for the APs. Hybrid cables need to be made on-site. This video will demonstrate how to process a hybrid cable, assemble optical fibers in mechanical splicing mode, assemble optical fibers in fusion splicing mode, assemble copper cores, and connect a hybrid cable. Before we start, let's get the installation tools ready. Different tools and auxiliary material packages are required for assembling optical fibers for hybrid cables in the mechanical splicing and fusion splicing scenarios. In the mechanical splicing scenario, you need to prepare the tools yourself and purchase the 02233FKY auxiliary material package. In the mechanical splicing scenario, you also need to prepare the tools yourself and purchase the 02233FLB auxiliary material package. Tools and auxiliary materials for assembling power cores. Processing a hybrid cable. First, use a utility knife or a cable stripper to peel off a 400 mm long section of the outer sheath from one end of a hybrid cable for connecting to a switch, and peel off 300 mm from the other end for connecting to an AP. You are advised to peel off the outer sheath in 2 or 3 sections, allowing the outer sheath to be easily peeled off and preventing optical fibers from being broken. Then cut the wrapping tape to expose the optical fibers and DC copper cores. At both ends, use insulation tape to wrap around the position where the outer sheath is peeled off. Cut the copper cores or optical fibers connected to a switch depending on the side of the cabinet along which hybrid copper fiber cables connect to the switch. Note that electrical ports reside on the left side and optical ports on the right side. Assembling optical fibers in mechanical splicing mode. Optical fibers in hybrid cables can be assembled in one of 2 modes: mechanical splicing and fusion splicing. Let's first look at mechanical splicing mode. Use a flat drop cable stripper to remove the unwanted fiber jacket and ensure that there is at least 50 mm of bare fiber. Note that using diagonal pliers may damage the optical fiber and is therefore not recommended. Bend the bare fiber to an angle of about 60 degrees in the upward and downward directions, 3 times in each direction, to check whether the bare fiber is broken. Ensure that the cut surface is neat and even. The optical fiber is not damaged, and the steel wire in the jacket is not bent. Open the fiber clamp and insert the optical fiber. Close the fiber clamp and press it tight. Ensure that there is no gap between the fiber clamp and the cut surface, and the optical fiber is pushed down to the bottom of the fiber clamp. Place the assembly inside the fiber holder. Place the fiber holder inside the fiber coating stripper, squeeze the fiber coating stripper, and pull out the fiber holder at an even speed to remove the fiber coating. Be sure not to tilt the fiber holder when pulling it out, otherwise the optical fiber will break. Check and clean the bare fiber. Bend the bare fiber to an angle of about 60 degrees in the upward and downward directions, 3 times in each direction to check whether the bare fiber is broken. Clean the bare fiber with pure alcohol using a piece of dust-free paper. Rotate the bare fiber 90 degrees and then clean it again in the same way. Place the fiber holder on the fiber cleaver. Cut the optical fiber. Ensure that the bare fiber is not bent and there is no gap between the fiber holder and fiber cleaver. Take out the assembly from the fiber holder and use the fiber holder to check the fiber length. Assemble the optical fiber. Assemble an LC connector that has a wedge unit firmly seated. Gently insert the optical fiber until the fiber clamp is entirely within the LC connector. You will hear a click. Do not touch the end face of the LC connector when performing this operation. Inspect the bare wire on the LC connector. The bare fiber should be slightly bent and should not protrude from the LC connector. Remove the wedge unit. The assembly is now complete. Do not overly bend the optical fiber near the connector. If the optical fiber fails the performance test, disassemble and reassemble it. Seat the wedge unit on the LC connector. Press the wedge unit first at part 1 and then at part 2 until you hear a click. Place the fiber clamp release tool at the hole on the connector and slide it to withdraw the fiber clamp. Pull out the optical fiber. Assembling optical fibers in fusion splicing mode. In addition to mechanical splicing, an optical fiber can also be assembled in fusion splicing mode. Feed one end of an optical fiber and one end of a pigtail through the caps of a fusion splice protection sleeve. Additionally, feed the optical fiber or pigtail through 60 mm of heat shrink tubing. Then remove the fiber coating and clean the bare fiber in the same way as in the mechanical splicing scenario. You need to purchase the 02233FKY auxiliary material package, which contains the required tools, such as the fiber holder, fiber coating stripper, and fiber clamp. You can also use Miller pliers instead of purchasing this package. Process the pigtail. Use Miller pliers to strip the jacket and coating of the pigtail. Use a fiber cleaver to cut the pigtail. Then clean the pigtail using pure alcohol. Place the optical fiber and pigtail into a single-core fiber fusion splicer. Use a 0.9 mm trough for the pigtail and a 0.25 mm trough for the optical fiber. Power on the fiber fusion splicer to fusion splice the optical fiber and pigtail. Slowly cover the splicing points and bare fiber using the heat shrink tubing. Secure the heat shrink tubing to the heat shrink trough and start heating it. When heat shrinking is complete, remove the spliced optical fiber. Place the spliced optical fiber into the fusion splice protection sleeve and tighten the caps at both ends. Repeat the preceding steps to fusion splice the other optical fiber. Assembling power cores. Peel 8 mm of insulation coating off each power core. Fully raise the levers of a power connector as shown in the video. Insert the copper cores all the way into the cable inlets. Ensure that no copper conductors are bent or exposed. Lower the levers and look through the observation windows to verify that the springs do not overlap with the insulation layers. Pull each copper core with a force of about 10 Newton and ensure that each copper core is properly connected. Bind the copper cores with cable ties in the same direction and cut off the excess cable ties. Connecting a hybrid cable. Remove dust plugs from the optical ports on a switch and an AP, and install optical modules. Connect the LC connectors at one end of a hybrid cable to the RX and TX ports of an optical module installed on the switch, and connect the RJ45 connector at the same end to a multi-GE port on the switch. To ensure convenient cabling, a hybrid cable must be connected to a multi-GE port and an optical port with the same number. Connect the LC connectors at the other end of the hybrid cable to the RX and TX ports on the optical module installed on the AP, and connect the RJ45 connector at the same end to the PoE port on the AP. Connectors at two ends of each optical fiber in a hybrid cable must be connected to the TX and RX ports on optical modules, one end to a TX port and the other end to an RX port. The recommended optical fiber connections are provided in the table. Check the indicators. If the indicator on the AP is on after the cable connection is complete, the AP is powered on and can communicate with the switch.